Hi guys. So today we're gonna be working on lesson 7. Hold up. Yeah, lesson 7, which is actually gonna talk about a connection between equations and then percentages. But before we do that, I just want to spend some time reviewing some things that were in the video yesterday and reviewing some things about decimal multiplication because we're gonna need that today. So first thing before we get started, I actually want you to take out your notebooks. Okay. Um, you can title this. We're going to just put a title on this real fast. We're going to put fraction equation and decimal multiplication review. Okay, you can put that on their table of contents if you want to. This is just something I just want to touch on and make sure we're okay with before we start into today's lesson, because these are skills that we are going to need to be successful for what we're going to do today. So we're just going to start with fraction equations first. So this is going to be example 1. And we're going to start with this idea of 2/3. Let me put a box around this. 2/3 equals, actually I'm going to move that over a little bit. Sorry guys. 2/3 equals 3/4 x. Okay, now yesterday we talked about different ideas to look at this in terms of what does this 3/4 mean. So we have this 3/4 right in front of this x, and there's no operation in the middle. There's nothing there. So we can say there's an invisible multiplication sign that shows up. Now yesterday as well, we talked about that this meant 3 times x, and this meant 4 divided by x, because it's the denominator of a fraction. So what we're going to do in this case is we have to deal with both. So if I'm multiplying by 3, the way to get rid of that, or to make that kind of cancel and become a 1, is to divide both sides by 3. So now I've taken care of this guy. If I'm dividing by 4, the way to cancel, undo, get rid of, however you want to think of it, is multiply both sides by 4. And we talked about this guy yesterday being called the reciprocal. Now, if I do it to this side, I have to do it to the other because this is like a scale. It must stay balanced. So now I'm going to get the 3 and the 3. Those cancel. The 4 and the 4. Those cancel. So I'm left just with x. On this side, this becomes 4 times 2, which is 8. In the denominator, I have 3 times 3, which is 9. So my answer is x equals 8/9. Okay, let's do another one. Okay, let's do 4/7 equals, 9/11 m. Why not? Let's do a different variable. Okay, so right now I have 9/11 and an m. There's nothing in the middle, so I know that there's a little multiplication sign that can go there. So I have two pieces, a 9 and an 11. It's being multiplied. So I need to undo this. I need to get this m by itself. So I'm going to go to both sides. If I am multiplying by 9, the way to undo that, make it go away, is to divide both sides by 9. If I'm dividing by 11, the way to make that kind of go away is to multiply both sides by 11. If you notice now, it was 9/11, it becomes 11/9. This is a reciprocal, which is kind of just a fancy way of saying I'm doing the multiplication and division step, the undo piece, all at the same time, just with one fraction. So my 9s cancel, my 11s cancel. And on this side, I'm left just with m. Over here, I'm going to get 11. Oh, there's nothing there, so an invisible multiplication. get 11 times 4, which is 44, over 9 times 7, that's going to give me 63. Okay. All right, let's do another one. Okay, let's do, let's see, I don't know, 5/12 p equals 3/7. Okay, so I find that my variable this time's on the left-hand side. That's totally fine. I have 5/12, then there's a p directly next to it, and I can notice that there's no operations in between there. There's no addition, no subtraction, so I know I automatically can put a multiplication sign there. So now I'm going to try to undo this or get this 5/12 to go away. So on both sides, it's an equation, I have to stay even. If I am multiplying by 5, the way to get rid of that is to divide both sides by 5. If I am dividing by 12, the way to undo or get rid of that is to multiply both sides by 12, which creates this fancy guy here, which again, we call him our reciprocal. All right, so on this side, I have a 12 and a 12. Those can cancel, a 5 and a 5. And I'm left with p equals. This side I have 3 times 12, which is going to give me 36. 7 times 5, which gives me 35, which is my answer. Now, some of you might notice that the 35 is larger than the 36, so if you want to write it as 1 and 1/35, you could do that too. Both are correct. Okay, let's do another one. Okay, example 4. We're going to do 100/7 equals 100/14 times x. Okay, so my x is now on the right-hand side again, so I need to take and get rid of this 100/14. It is a fraction, it's being multiplied. So how do I get rid of a multiplication of 100? Well, I divide both sides by 100. How do I get rid of this division of 14? Well, I multiply both sides by 14. Okay, over here we can see that the 100 cancels and the 100 cancels. The 14 cancels and the 14 cancels. So on this side, I'm left with just an x. Now, if you take a look over here, you might notice something. See how on the right-hand side, I have 100 in the in the numerator and a 100 in the denominator? That's the same, you can kind of think, as 100/100, which is equal to 1. So when we say something is canceling, it's really becoming a 1. Because when we multiply anything by 1, it's just itself. Because then 1 times x is just x. So the 1 cancels. But on the left-hand side, you actually might notice something. They're 100 and 100. So even on the left side, if I see what we call a match, those can cancel. So then I'm left with 14/7. Now, if you're real savvy with those multiplication skills, you might notice, well, 14 goes into 7 2 times. Oops, sorry, guys. All right, let's do another one. Okay, we're going to do 25/3 equals 75/2. Let's go with r this time. All right, so I have 75 over 2 and an r. There's nothing happening in between. There's no plus or minus signs, so I can assume that technically a little multiplication sign will go there. Now my goal is to get the r by itself, which means I need to kind of find a way to cancel or get rid of this 75 over 2. So if I am multiplying by 75, the way to undo that is to divide both sides by 75. If I am dividing by 2, the way to get rid of or undo that is to multiply both sides by 2. So over here on the right-hand side, the 75 and the 75 cancel. Here on the left-hand side, the 2 and the 2 cancel, and still on the right-hand side, and I'm left with just an r. Now I'm going to take a look on the left-hand side, and there's something I do want you to notice ahead of time. Now, over here we had 75 and 75, and those just kind of canceled right off the bat. Now, if you look here, we don't have anything that matches 100%. It's not like I have a 25 and a 25 in the bottom where they could just go away. I have a 25 and a 75. But what's interesting about this 75, though, is 25 and 75 do kind of have a relationship. How do you get from 25 to 75? Well, think about it. 75 really is 3 times 25. So if you ever see anything that you notice there's kind of a relationship, I can then take these 25s and I can kind of reduce them. So that means I'd be left with 2 on the top and then 3 times 3, which gives me a 9. I would have r equals 2/9. Okay, I know that was a little bit crazy, so let's do another one. Example, what are we on? 6? 6. Okay, let's do 4/9 equals, let's see, 16, I don't know, fifths m. Okay? All right, guys, when we look at this, we have 16 fifths. Well, I can take both sides. I need to get rid of this multiplication of 16 fifths. So if I'm multiplying by 16, I divide both sides by 16. If I'm dividing by 5, I'm going to multiply both sides by 5. Okay, on the right-hand side here, we can see that the 16s can go away. They're going to cancel and become a 1. And the 5s go away. Those cancels and become a 1, which leaves me with just an m. Now on this side, 5 and 9 can't cancel, and I can't think of any relationship that they share. 4 and 16 can't cancel, but 16 and 4 might have something in common. I can think of 16 and 4 as 4 times 4. So instead of thinking of it as 16, I'm going to think of it as 4 times 4, which means my 4 cancel. I'm left with 5 over 4 times 9 is 36. Okay, we're going to keep going through that, but that was just a warm-up of all of those today. Before we get started, I just want to do one quick multiplication of decimals review because it's been a little bit. Okay, and I just want to do 2 2/10 times 54. I'm actually going to change this to be a dot instead of an X. Sorry about that, guys. Okay. Now, last time we talked about, this is called 2 2/10. So instead, we're going to think of this as 22 times 1/10. Oh, goodness, I wrote that X again. Sorry, guys. My brain is in equation mode. Times 54. We then talked about we would take our whole numbers, 22 and 54, and then we would multiply them. So I have 22 times 54. Okay? 4 times 2 is 8. 4 times 2 is 8. Okay. I'm going to go over to the next place value, which means I'm going to add a 0 because now I'm thinking about this as 50. Because originally we were thinking about as 4 times 22, then 50 times 22. So 5 times 2 is 10. Carry the 1. 5 times 2 is 10, plus 1 is 11. So I'm going to get 1,188. This now becomes 1/10 times 1,188, which means we move the decimal over one place to the left. I get 118 and 8/10. All right, guys, that's our warm-up. I'm going to stop this video, and then I'm going to make another one that goes over lesson 7.